Welcome to this Unconventional Machining Process course, and the course code is ME8073, and this course is a professional elective 2 for the mechanical engineering students for the regulation 2017. And in this video session, we'll be studying about recent trends in non-traditional machining processes in Unit 5. So in this process, you have the syllabus, and the objective of this non-conventional machining process is to learn about various unconventional machining processes, the various process parameters, and their influence on performance and their applications. And the syllabus for the 5th unit, recent trends in non-traditional machining process, will be studying about the recent developments in non-traditional machining processes, their working principles, equipments, and the effects of process parameters, and its applications, advantages, and limitations, and the comparison of non-traditional machining processes. So these are all the textbooks and reference books for this course, Unconventional Machining Processes. And this unconventional machining process, the course outcomes are the students, upon completion of this course, will be able to explain the need for unconventional machining process and its classification from Unit 1. And from Unit 2, they will be able to compare various thermal energy and electrical energy based unconventional machining processes. And from Unit 3, the students will be able to summarize various chemical and electrochemical energy based unconventional machining processes. And from Unit 4, the students will be able to explain various nano-abrasives based unconventional machining processes. And from the 5th unit, the students will be able to distinguish various recent trends-based unconventional machining processes. So, introduction to recent trends in non-traditional machining processes. So, new trends for machining. The machining process are of great importance in the productive activity. So both directly for manufacturing of the components and for indirectly the manufacturing of auxiliary elements, namely such as tools, and the tools required for manufacture of components by other injection processes. And the technology related to machining has evolved a lot in recent years with improvements that would affect multiple fields such as the cutting tools, machining technology, the means of production, and the CAD, CAM or sensors. However, there is still room for improvement in machining processes through the use of new technologies and optimization, and based on the greater knowledge of the processes. So the most prominent areas of work in the field of unconventional processes are the following. The first one is the laser beam machining, and the second one is the ultrasonic machining, and the third one is the electrochemical machining. So coming to the principle of this first one, that is laser beam machining, which we will be studying in this video session. So this laser beam machining is a process which works on the basic principle of a laser. So in this machining process, a laser beam is used, which is nothing but a monochromatic high intense light that can cut any metal and non-metal. So here the laser machining can be used to cut and remove material from even the hardest material present, which is a diamond. So here this is a laser beam machine setup where you can see you have this flash lamps, and you have a ruby crystal inside this flash lamp, and you have the reflecting mirror on the top of the ruby crystal, and you have a partially reflecting mirror at the bottom of the ruby crystal, and you have a lens which focuses the laser beam into the workpiece. So this Flash lamps, is connected to a power supply through a capacitor, and the laser beam produced from the ruby crystal are made to focus to a point on the workpiece by this converging lens, and thus the part which is focused by this laser beam, the material is being removed. So this is a basic principle of the laser beam machining. And coming to applications of laser beam machining, this can be used in wide range of manufacturing applications and can be used for material removal, drilling, cutting, and uh, trepanning, and used for laser beam machining, and can be used for the cladding, alloying. And in laser drilling, the laser beam is focused over the desired spot size, and this is used for thin sheets. Pulse laser can be used, and for thicker one, continuous laser may be used. So advantages of laser beam machining: it can be used to cut any material, and no tool cost because no physical tool is required, hence no cost for maintenance and replacement of tool. So no delamination is caused because no physical contact with the workpiece, and it's easily automated and is very flexible also. And this laser beam machining can be carried out for these complex shapes of different sizes, and can be moved in any path. Good surface finish is obtained by this laser beam machining, and micro holes can be drilled in workpieces with high accuracy. So disadvantages of laser beam machining is very high capital and maintenance costs. It cannot be used to produce a blind hole, and it leads to safety hazards. So with this, we come to an end to this video session of this 5th unit. So thank you and have a great day.